Good evening, everyone. My name is Jyoti Sharma, and this is week 5, and the session will be from 6 to 8. Here is my brief introduction that right now I'm a PhD student in ISA Bhopal and in Earth and Environmental Sciences. My master was in Environment Management from FRI, and my undergraduation was from University of Delhi, and I already have taken some courses on NPTEL, so I think that will help me to move with this course in a nicer way. And I have cleared net GRF in environment science. And how we will proceed is that I have a lot of MCQ question and we will try to solve it. And the solution of this will be with the discussion. You will tell me something like whatever you are thinking that this one is the right answer. You are welcome to write in the chat box whatever you are thinking that the right answer. Even if it is wrong, then don't worry because I'm here to correct you, and this will be the win-win situation because you will learn from me and I will also learn from you. So yeah, discussion is the best part that we may have in this live session, and I encourage you people to participate. You can write in the chat box, even you can speak whenever you are thinking like appropriate. So, and we started with first week. So I'm just giving you the brief what we have covered till now because this is the week 5, and we already have covered 4 weeks, right? And so in week 1 we started with the parameters that we are interested in to quantify the water quality, to quantify the air quality. For example, if I'm taking the example of one parameter such as taste or color, then we moved to BOD, COD, theoretical oxygen demand. So such type of parameters, we learned that these are the parameters by which we can quantify the quality of the water. And even we talked about the particulate matter and what different particulate matter we may have. Then we moved in the second week, and in the second week, what we tried to learn is that whatever contaminant we have, so we tried to understand affinity of that contaminant to move to air or to move to the water or to move to the soil. So this is known as the partition constant. We talked about this partition constant at length because the any contaminant, that any contaminant will have some physical and the chemical property, and if that physical or chemical property is matches with the chemical or physical property, let's say of the liquid or gas or solid, based on that it will go to that place. So for example, if I have something carbon or hydrocarbon compound, if I have, and if I have clay soil, because the clay soil also have hydrocarbon, then this carbon compound I have in the soil. So the affinity of this contaminant A, for example benzene, or another example you can take any contaminant, so its affinity, whether you may have that contaminant more in the air or water or in the soil. So this is what we try to learn, and this partition constant is very important for us to learn, to understand whatever contaminant we have, where it will be present, right? So we learned it in week 2. Then we moved to week 3, and here we started how we can, so we talked about parameters, right? We talked about BOD, COD, but the thing is how we can monitor it, how we can sample it. And for that we should have some procedure, we should have some instrument. Before that instrument there will be some pre-processing. We learned about something, so that we have some confidence, whatever interpretation we are giving or whatever result we are giving, we should have some confidence, right? And for that confidence, there is quality check and quality insurance things that come into the picture. So we learned about some monitoring and sampling of some contaminant, about the calibration we learned, the precision, and yeah, replication. We learned about these things in week 3. Then in week 4 we continued this, and yeah, week 3, I think this was all about the instrument, the quality, how we can check, how to make the standards, what is the role of the standard, such kind of things we tried to cover in week 4. Right now, because this is week 5, so we are moving ahead. So now we will touch some instruments that we need. For example, if we have any organic compound or hydrocarbon, then we need, most of the time we need gas chromatography, right? What is the principle of gas chromatography? What different detector we can use? Second thing. And uh, what we also have to do some pre-processing of the sample, right? The sample will present in, let's say, in the air, but you can't pass that air to the gas chromatography, right? uh, you have to move that contaminant into some liquid, so there is a pre-processing. So the thing is, we will learn about that pre-processing. We will learn about some instrument, for example, liquid chromatography and gas chromatography. We learn about this. We will touch mass spectrometer, and yeah, so and most of the time, in this week we will touch how we can measure organic part, right? But if I remember, in week 4, the last part, we have some type of blank. Um, um, if you people have studied chemistry, then you must know about the blank and the importance of blank. So we had few questions that were left, because time was over, past week. So we have 4 or 5 questions related to the blank, and then we will move to this week 5 content. And again, I encourage you to please write the option that you are thinking is right in the chat box, and please don't worry, because I'm here to correct you. Okay, so I'm starting with the MCQs. I have a lot of MCQs so that you can revise, and uh, these MCQs are related to all the topics that has been covered. So I think that MCQ will help you to understand even the syllabus that has been uploaded on NPTEL. Okay, so the first question is, if you are having the loss of sample during storage, what will happen? So I have 4 options: false positive result, overestimation, false negative result, increased precision. You can write in the chat box whenever you are thinking like A should be the right answer or B should be the right answer. You can just, so that I can understand that we are on the same page. Okay, so I got A answer and C answer. Okay, so I agree with the C answer, and let me tell you why it is not A. So positive result means, let me have the pen. So let's say we have any compound. Let's say if it is a contaminant A, and initially we had this contaminant 1 mg per liter, right? And this sample has been lost, right? This has been lost, and after that, after when instrument took the reading, what we found is zero point 0.7 mg per liter. So what we are thinking, that that particular contaminant is less in amount, but this is not the case. It should be 1 mg per liter, but our instrument is giving zero point 0.7 mg per liter. So this means that this is giving us the negative result, and this negative result is false, because it should be 1 mg per liter, and that's why C is the right answer. If there may be false positive result if it can give us, let's say, 1.3 mg per liter. There may be some case. So for example, you have some instrument, and within that instrument there may be presence of that contaminant A already. And if you are giving 1 mg per liter, that can give you 1.3, but that would be the case of false positive result. But if it is giving you, but if there is a loss means there will be the decrement in the concentration, and that's how this is giving us the negative result. So the C answer is the right one. A answer will be right if there is not loss, but there is a gain, right? And that's how the C answer. And yeah, this is very important because, for example, we if we are talking about Delhi pollution, and if we are measuring some gaseous pollutant, and if that gaseous pollutant, if we are measuring it and it is giving us less value because we are losing some sample during storage, then the seriousness of that pollutant will be lesser, because we are saying that, oh no, we don't have much concentration of that particular contaminant. And that's how that decision based on that false negative result can be the serious and can be harmful for us, right? So that's why it is very important. So whenever there is a loss during storage, you have to have take into the consideration. So I don't think that there is any problem with the false positive or the negative result. Okay, so we have a blank sample that show concentration above method detection limit, the most likely indicate. So good instrument sensitivity, matrix effect, true environmental contamination, and contamination in reagent or apparatus. You know what do you mean by blank? So in blank, most of the time we do not have the sample, right? So blank is something we are adding all the reagents or some compound, but we do not have, or it may be that we have the solvent only, but we do not have sample in it. And then we are measuring it in the instrument, and what we are getting, that concentration is above method detection limit. Okay, so okay, let me tell you again. Let's say this is contaminant A that we have. This is like and with this we have this solvent, right? So A plus solvent, and we have, let's say, solvent here. We do not have A. Then we are measuring these things in the instrument, right? So here the concentration should be zero, right? The concentration should be zero. But what I'm saying, and because this is blank, we do not have any contaminant in it, or interested compound we do not have. Here we have A, that we want to measure the concentration, but here we are not putting anything because this is the blank. Now we are measuring it, and the instrument is showing the value more than method detection limit. Okay, so it means it is giving you some positive result, right? So let's say if it is giving me the value more than zero, how blank can give me the value more than zero? What can be the likely cause for this? If blank is giving me value more than zero, it means there is something that like something wrong is here. So actually, okay, I'm coming with option by option. If we have good instrument sensitivity, if it will be the good instrument sensitivity, then for the blank, the answer should be 0, right? So this is not the right answer. Metric effect. What happened in the metric effect is, um, you have for example, we have distilled water and we have pond water, right? And after that, and in both in this both type of water, if we are adding some contaminant A, and then we are calculating the concentration will different, because the pond water property is very different from the distilled water, and there may be some reaction of this contaminant A with the pond water, and that's how the value may be different. But here we are not talking about contaminant, we are just talking about the blank sample. Blank sample means we are not adding any interested component in it, right? So that's how matrix effect is not the right answer. Then we have two options. True environmental contamination. True environmental contamination and the contamination in reagent or apparatus. So if it is a true environmental contamination, then it is not the blank, right? Because the blank already have some A, so it will not be considered as blank, because already environment have given some component A into the blank, and that's why um, this will not consider as the blank one. So this is this can be right, but this is not the right. The remaining one is the contamination in reagent or apparatus. So yeah, it can be, because we are having the blank, we are making the blank, but it may be that this apparatus or this beaker may already have attached a something here. Or you can say that if we have some instrument, and if in that instrument we are adding a blank, instrument may already have some A, and that's how it is giving value more than 0. Blank should give us the value 0, because it should not give us the value above the method detection limit, right? uh, and yeah, uh, uh, I'm just taking 0 here to make you understand, but it may be less than 0 also, so it may be like 10 raised to power minus 2 or something. So you already know about this method detection limit, so this is the limit uh, above which the instrument can measure something, right? So D answer is the right one. So yeah, 3-1 is little trickier. You can say like C is the right answer, but more appropriate answer is D. Okay, so I think if it is a clear, then we are moving to the next question. Okay, I think this is the simple one. Which of the following is an example of sample gain? In what conditions sample can be gained? If sample is 1 mg per liter, but if you are measuring is 1.5 mg per liter, so it means you have gained some sample, right? So how you can gain some sample? Evaporation during storage, adsorption onto container walls, carryover from previous injection, biodegradation. So yeah, I got C answer from everyone. And yeah, C answer is the right one, because evaporation will give us the loss. Adsorption will give us the loss. Carryover will give us the gain. Biodegradation will give us the loss. And that's why C answer is the right one. Okay, so I took this the NPTEL slide from Sir only, and what it is showing us is that we have different way by which we can gain the sample. Gain the sample means addition of analyte into sample, and it may be the contaminated apparatus. We talked about it. There may be dirty glassware, container. There may be some transfer equipment that can be dirty, and the instrument may also be dirty. That is the sample memory, that carryover thing, right? And sample may also have that dirty solvent or deposition from the environment. So yeah, or there may be some reaction. So we have a lot of ways by which the sample can be lost or gained while pre-processing before going to the instrument, right? And that's how we have to take care whenever we are doing sampling. Okay. The next question is, okay, we have four type of blanks, and which type of blank is used to detect contamination introduced during the entire analytical procedure: extraction, concentration, analysis. And we have four blank type: method blank, instrument blank, calibration blank, and internal standard. So, whenever you are analyzing, whenever you are trying to get the concentration of any contaminant, then or any analyte, it is important for us to create some blank, so that whatever the error we have while extracting, while concentrating, while analyzing, that we already know, so that we can remove that uncertainty, or we have some confidence. Okay, that much percent of confidence we have that this is the correct concentration. So we have four type of blanks, and the question is giving the description of one type of blank. Any guess? Don't worry, I will discuss one by one all type of blank. Okay, the answer should be method blank. As I told you, whenever we are extracting, for example, we have some contaminant, and let's say that contaminant is, we want to measure carbon monoxide from the air, right? How much concentration we have in the air for this carbon monoxide, but we can't measure it directly. First we have to have this carbon monoxide in some liquid or in some solvent, let's say. So this is known as the extraction. So first what we are doing, we are changing the background. Background was air, but we are changing it to some solvent, or if mostly it is the liquid, right? So this is known as the extraction. And while extraction, there may be some loss or gain of this CO. Okay, then we have to create a blank here also. Then it may be that the concentration of the CO in the solvent is very low, but for the instrument we need more concentration. So what we are doing is, we are having more CO in less liquid, right? So this is what we are doing is concentrating, and then we are analyzing. And at each step there may be some error, there may be some uncertainty, there may be some issues, there may be gain or loss. And if we are considering all gain and loss at each step, that type of blank will be known as the method blank. So what we are doing is, uh, here we are having this solvent, right? We have this solvent and we are not adding anything into that. We do not have CO here, but then we will go into the step concentration also, and then we will measure it also. It means we will follow all the step will nothing, right? So that's how this will also give you the value of the method blank. But if we are not going to this step, but if we are starting from this step only, or if we are starting with this step only, so this is how the blank name will be changed. But if we are considering all steps in the blank, then this will be considered as the method blank. So that's how A answer is the right one. Okay, so we have four type of blanks, as I told you. In instrument blank, what we are doing, so as I told you, we have three step, right? We have extraction, then we have concentration, and then we have um, analyzing it in the instrument. So if we are directly analyzing, right, if we are not going through the extraction or concentration, if we have some blank sample, and that blank sample we are directly analyzing it in the instrument, that will come under the instrument blank. So it means it is not undergoing through the extraction process, right? uh, Method blank, we are going through the extraction also, even concentration and then analysis, so we are following all the steps for this blank. For the calibration, this is just like instrument blank, but it is little different from it. Okay, then the internal standard, in internal standard, we are adding analytes here. It is not completely blank, we are adding some analyte, but known amount of analyte, and then we are seeing whatever variability we have, internal variability. And that's how at uh, if we want to know the overall error, then we will go to the method blank. Okay, at each step there may be some error, and then whatever the last error we have, so we will go with this method blank. If we want to just know whatever error the instrument is giving, then we are not going through that extraction or concentration process, we are just making the blank, and we are analyzing it in the instrument, so we are checking the instrument contamination. For the calibration, for the calibration we are having some standards, and based on that we are doing it. And for the internal, we are having the known amount, and then we are going through the extraction process, and then we are seeing the error. So at each step, if we want to get to know the error, we do have different type of blanks that we can create, right? And that's how for the method blank, uh, it will go through the extraction. So that's why this answer is the right one. Okay. Now the week 4 content has been cleared. Now we are moving to the week 5, and in the week 5 we have BOD, COD. What are the formula for these? What are the things that we need to take into the consideration, and then we will move to the instrument part. Okay. So we have one test that is known as BOD5 test. It is performed under which condition? We have four options: 3 days at 25 degrees Celsius in light, 5 days at 20 degrees Celsius in dark, 7 days at 37 degrees Celsius in dark, and 5 days at room temperature in light. What do you think? What should be the right answer for this? If you know that BOD is used to get about the concentration of organic matter that we have in the water, because that organic matter will make that water contaminated, right? So let me see the answer. Okay, Preeti and Chechi gave me a B answer. Yeah, I also agree with this B answer. But here we have three things. The first thing is 5 days. Why 5 days? The first question is why we are having the 5 days. Second, 20 degrees Celsius. Why it is 20 degrees Celsius? And dark. Why it is dark? So first, why it is 5 days? Why it is not 7 days or 10 days or 15 days? Any hint about this? Why this is 5 days only? Why not 7 days, 10 days, 15, 3 days, 1 day? So what we do is, we have water sample, let's say. We are calculating the dissolved oxygen at time 0, and then after 5 days we are again measuring the dissolved oxygen after 5 days, and then we are subtracting it. That's how it will give us the BOD. Okay, I got some answer that since microorganisms are used, uh, microorganism will also active after 5 days also. So this is not the direct answer, but yeah, there is something that is missing, the type of microorganism. I think with that, I think you biodegradation process take that time. Yeah, but even after days also biodegradation can happen. Deepa gave me little right answer, that is nitrosomonas. Okay, I think that can explain it better, because if you have this time, right, if you have this time, what you will get to know that BOD or something. So what you will get to know is that after 5 days, yeah, Deepa gave me the right answer. After 5 days, nitrate producing bacteria are more. So within 5 days, most of the biodegradation is for the carbon compound. Okay, but after 5 days, the nitrogen based bacteria will be active, and there will be biodegradation of nitrogen based compounds. So, and so that's why we are mostly interested in the carbon compounds only, the decomposition or the degradation. So that's why we are keeping this the window of 5 days, because after that there will be the biodegradation of the nitrogen based compound. Okay, okay, so this is clear why we are having the 5 days. The second is 20 degrees Celsius. Why it is 20 degrees Celsius? Why it is 20 degrees Celsius? Why we are measuring that dissolved oxygen at 20 degrees Celsius only? Okay, Priti gave me ambient temperature for growth. Yeah, I agree with this. And Deepa told me universally accepted as a standard and suitable. Yeah. So as I told you, this is the standard, right? This is the standard, APHA 5210B. It means that if you are measuring that BOD at different temperature, the BOD will be different, right? So there should be one particular temperature, and that temperature also should be good for the growth also. So that's how 20 degree is well enough to take. Then the third is dark. Why it is dark? Why it is dark? Why whatever BOD bottle we have to keep in the dark? Why? Cheche gave me a response to prevent photosynthesis. And what photosynthesis will do? You are right. But what is the role of the photosynthesis? Okay, so used oxygen. So yeah, so you're right. So what happened is, whenever we have the photosynthesis, photosynthesis will give you the oxygen, right? Photosynthesis will give you the oxygen. So uh, whatever DO, dissolved oxygen, should be lesser for us, but if we are having the light, then this dissolved oxygen even after 5 days it can be more if there is a more photosynthesis, because photosynthesis will give you the oxygen. And so this will not give you the correct BOD, because BOD is something that uh, oxygen amount will be more. Yeah. So after some days oxygen amount should be reduced, but if we are have the photosynthesis in the light condition, then photosynthesis will add more oxygen. So, and if it is adding more oxygen, so this BOD is nothing but the biological oxygen demand. We are not depleting it, but we are increasing it. So our test will not be valid if we are keeping that in the light condition. So that's how it should be for 5 days. It should be at 20 degrees Celsius and it should be in dark only. Yeah, that's what I wanted to say here, that this is up to 5 days. We are mostly sure that this will give us the carbonious or the carbon based biodegradation, but after these days there will be the nitrogenous, so other type of bacteria will come and will cover that water. And yeah, one more thing that you have to see is that BOD here is just for the 5 days, but after 15 or 20 days there will be the biodegradation of the nitrogen based compound. And there again we have oxygen will be depleted, and overall how much oxygen has been depleted will give you the ultimate BOD. And ultimate BOD will always be higher than the BOD 5, right? I think you are knowing it already. Okay, I think very simple question, but yeah, I have to ask this just to know whether you know it about it or not. So, if our initial DO is 8 mg per liter and DO after 5 days is 3 mg per liter, what is the BOD 5? 3 mg per liter, 11 mg per liter, 8 mg per liter, or 5 mg per liter? How you will calculate the BOD? What is the formula for that? And if you know the formula, I think this is the easiest question that I asked you. What will be the answer if DO, initial DO is given and DO after 5 days is also given? Then can you calculate the BOD 5? What is the formula of BOD 5? BOD 5 formula is initial dissolved oxygen minus final dissolved oxygen after 5 days. Initial dissolved oxygen is 8 mg per liter. After 5 days, the dissolved oxygen is just 3 mg per liter. What will be the BOD 5? Yeah, so this will be 5 mg per liter. Yeah, D answer is the right one. So 5 mg per liter. So it is just like that. Initially you had the oxygen concentration 8 mg per liter, but after 5 days the oxygen concentration has been reduced to 3 mg per liter. So it means 5 mg per liter of oxygen has been consumed. So this is your biological oxygen demand, right? And that's why 5 milligram per liter is the right answer. Okay. Next question is, if you have a water sample, right? And dissolved oxygen, initial dissolved oxygen is 8 mg per liter. And even after 5 days, the dissolved oxygen is same. it means 8 mg per liter only. So it means that BOD5 is equal to 0 mg per liter. But what can be the likely reason for that? So we have four options: sample contain toxic metal, non-biodegradable organic compound, deometer malfunction, temperature too high. Okay, so I got B answer and C answer. Uh, I agree with the B answer, not with the C. Uh, because as I told you, the initial DO is 8 and DO5 is also 8. So I'm giving you some value. You just need to subtract. So the DO meter malfunctioning is less as comparison to, or there may be some condition that DO meter is right. Then what can be the reason for this? So the reason for this is BOD is biological oxygen demand, right? So microorganism will consume some organic compound, right? But there may be some organic compound that are non-biodegradable. Okay, if such is the condition, then even if we have microorganism, even if we have organic compound, but if that organic compound is non-biodegradable, then DO will be the same, and that's how the BOD is just 0 mg per liter. There, okay. So the thing is, B and C both can be the answer, but if I go to the appropriate answer, then this should be B only, right? So I agree with B more as comparison to the C one, right? Okay. In the BOD calculation, whenever we are having the BOD bottle and all, we are having the seeding. So first question is, what do you mean by seeding? And second, why it is necessary for us to have the seeding? So we have four options. Sample has too many microorganisms. Sample contain toxic chemicals. Sample lacks sufficient microorganism. DO is very high. So Deepa Chechi, okay, you gave me C answer. Yeah, so you are right. C answer is the right one. But what do you mean by seeding? What do you mean by seeding? The first thing, and the second thing is why it is necessary. Okay, so I got answer. Add what you are adding. What you are adding, Chechi? Okay, so Cheshi gave me answer that in seeding we are adding the microbes. You're right. Sometime what happen is we may have contaminated water, and in that we have some organic compound. We have a lot of organic compound, but there may be some case that we do not have sufficient microorganism. We have like few microorganism, and then biodegradation is not enough because we do not have enough microorganisms. So if such is the case, then we have to add some microorganism, right? And then we have to calculate the BOD. So this is known as seeding, and yeah, C answer is the right answer. Okay, so the next question is, a wastewater sample contain high phenol concentration. DO does not decrease during incubation. The most likely reason is no organic matter present, sample lack microorganism, too much seeding, toxicity inhibit microbial activity. Okay, so yeah, what should be the answer for this? Chechi gave me D answer. Yeah, I also agree with the D answer only. uh, that if you know that whenever we have high phenol concentration, that can create toxicity in the water, and because being a toxic in nature, that can inhibit the microbial activity, and if microbes will not do any kind of activity, then there will be no biodegradation, there will be no any drop in dissolved oxygen, and that's how um, uh, the BOD will be zero. And you may be confused with the sample like organism. Most of the time, we do have microorganism. It may be that we do not have sufficient, but most of the time we have the microorganism. There should be drop in the dissolved oxygen. And if we are not having it, means there may be the toxicity within that contaminant, right? And that's how D answer is the right one. Okay. So you prepare a BOD bottle, um, 300 milliliter total volume using 50 ml sample and 285 ml dilution water. What is the dilution factor? Okay, I have two questions here. Why we are doing the dilution? First question, and then what will be the dilution factor in such the case? I said we have sample just 50 milliliter. So, for example, if there is a polluted river and we are having the polluted river water just 15 milliliter, and we are adding 285 milliliter dilution water or distilled water. Why we are adding that? Why we can't directly measure this 300 ml of the sample only? Why we are not measuring 300 ml of the sample? Why we are just measuring 50 ml of the sample and we are adding 285 ml dilution water? What is the need for that? And then we will come to the dilution factor. What can be what do you why there is the necessity for the dilution? Why we are mixing 15 ml of the sample with 285 ml of the dilution water or distilled water? What is the need for that? So it may be if you have high loading of organic compound. Okay, if let's say if we are having just 30 300 ml of sample only, right? Sample have a lot of organic compound, a lot of microorganism. It may be because we have a high loading, high microorganism concentration, that it may be after 2 days all the oxygen is depleted. We do not have more oxygen to deplete. Then what will happen? After 5 days, it will give me the wrong result, right? So it means whenever we have high loading of organic compound, um, it will deplete within few days. Okay, and then if we are having the dissolved oxygen after 2 days only, it is zero. Then what will happen after 5 days? It will be again zero. But that zero answer is not the right one. There should be more depletion, more biodegradation. So that's why what we are doing is we are doing the dilution. So we are diluting the sample concentration. Okay, so that we do not have that zero dissolved oxygen after 5 days, because zero will give you the wrong answer. We do not know when this dissolved oxygen has been depleted, right? That's why we do need the dilution. The second is, can you calculate the dilution factor for such case? So first we calculate the ratio of sample divide by total volume. So this ratio is, so let's say this ratio is P is equal to, or you can say the fraction of sample to the total volume of water, let's say. So first we are calculating P, and this P is 15. The 15 is the sample, and our total volume is this one, right? This is a fraction. Then if we are talking about the dilution factor will be equal to 1 by P. So uh, so dilution factor is something, how many time we have increased the volume as comparison to the sample. So this is something. So if we are reverting this 15 divided by 300, so this will be 300 divided by 15. So this will be 20. So it means we are diluting our sample 20 times, right? Because we have just 15 mg per milliliter sample, and if the dilution is 285, it means we are diluting it 20 times. And how we got this 20 time? First we calculated the ratio of sample versus total volume, and then dilution factor is 1 by P, right? So that's how, what will be the answer for this? The answer will be 20. So I have here a little explanation about this. So this is this fraction is telling you the sample make up just 5% of the bottle, because we are calculating the fraction, the sample volume divided by total volume. So sample is just 5% of the total volume of the bottle, but dilution factor is the sample was diluted 20 times. So there is a difference in P and 1 by P. 1 by P will be the dilution factor. Okay. So the next question is, if your initial dissolved oxygen is 6.8, dissolved oxygen after 5 days, it is 1.2 mg per liter, and dilution factor is 20. So what should be the BOD? 5. What should be BOD 5? Preeti gave me 112 mg per liter. Yeah, you are right. So you must have done, what you have done is you calculated BOD 5 just like 6.8 minus 1.2. So this will be something 5.6. But we have dilution factor 20. It means our concentration, the BOD demand will be higher, because this 5.6 value is when we have diluted our sample 20 times. Then BOD should be multiplied by 20, right? And this will give you 112 mg per liter. So we are multiplying our dilution factor with the dissolved oxygen, with BOD that we calculated after dilution. And that's why C answer is the right one. So I think you have already have calculated this way. Yeah. So if the dilution water blank, here we have blank, right? So DO initial is 5.8 mg per liter, dissolved oxygen after 5 days, this is 8 mg per liter, and blank depletion is zero point 0.5 mg per liter. The value should be added to sample BOD, ignored subtracted from sample oxygen depletion, multiply by dilution factor. Okay, so Deepa told me that this should be C. Yeah. This is something that even blank, if it is blank is giving the depletion of oxygen zero point 0.5, it means whatever our value will be, we have to subtract this zero point 0.5 from whatever value we are getting, because blank is also giving the depletion, right? So to remove that error, we have to subtract zero point 0.5 or blank depletion from whatever BOD we will get. So that's how C answer is the right one. So this is something like this. Um, Whenever we have the dilution, then we have to divide it by the P. And you know that that dilution factor is equal to 1 by P, right? So if we are so this 1 by P is equal to dilution factor, and so what we can do is we can remove this and we can also multiply with this df, dilution factor also. Okay, so there is a two way. If you have dilution factor, you can direct multiply by dilution factor, but if you don't have, then you can calculate the fraction of sample related to the total volume, and then you can divide it to the DO initial minus DO5. But here we were talking about this blank. So whatever blank value we will have, we have to subtract so that the error is minimized. Okay, so the next question is, why is dilution necessary in high strength wastewater sample? I think we already have talked about it. To increase DO, to avoid complete oxygen depletion, to reduce microbial activity, to improve temperature control. And yeah, Deepa gave me right answer, that is B, and we already have talked about this, right? We need the dilution because the oxygen can be depleted in few minutes or few hours, or within like 1 or 2 days. Then what will happen? This will give us the error. So that's how we have to dilute it, so that oxygen depletion should be even after oxygen depletion, the value should be more than 0. So that's how B answer is the right one. Okay, now we are moving little more to the COD. In the standard dichromate COD method, the primary oxidizing agent is, the first thing is you must have to understand what you mean by COD, and second is what primary oxidizing agent we use in COD. So we have four options here. KMNO4 in acidic, K2Cr2O7 in acidic, H2O2 in acidic, ozone in acidic medium. Okay, Chechi gave me B answer and Deepa also. So yeah, B answer is the right one. But what do you mean by BOD and how it is different from sorry, how COD is different from the BOD? Okay, Deepa told that for BOD is for the biodegradable organics. And what is COD then? Sorry, BOD is biodegradable organic. Yeah. What do you mean by COD? Both biodegradable and non-biodegradable. Yeah, you are right. So whenever we are talking about BOD, it means we are taking the help of microorganism to degrade the organic matter, right? So microorganism can only degrade whenever it is biodegradable only, but there may be some compound that are not degraded by the microorganism, so that we can degrade or oxidized using some oxidizing agent. So oxidizing agent not only oxidizing the biodegradable but also oxidizing the non biodegradable compound also. So that's how we have BOD and the COD. But we should have very strong oxidizing agent that can okay, Deepa gave me example lignin. Yeah, you're right, lignin is very difficult to biodegrade. But yeah, if we have some oxidizing agent, for example K2Cr2O7, it is easily to degrade or oxidize using such kind of oxidizing agent. So yeah, B answer is the right one. So, and it is very essential that we have this oxidizing agent with the acid, concentrated H2SO4, and these things will oxidize whatever we have hydrocarbon or organic compound, or we may have nitrogen also, so it will be converted to CO2, H2O, and um, ammonia, NH3, right? Okay, I think this is very important how we can calculate the COD. So first, what we do is we add KMnO4, potassium permanganate, but it should be in the alkaline condition, and this is oxidizing agent, but is not strong as dichromate we have. So this is the pre-processing or pre-oxidizing, right? So we are initially using potassium permanganate, but we can also remove this. We can come directly to the potassium dichromate. So we are so whatever sample we have, let's say we have pond water, so we are adding potassium dichromate in the pond water, and then what we are doing, uh, we are titrating it with FAS, and after adding the indicator, so whenever the color will be the change, so this will give us uh, how much uh, oxygen has been used to oxidize any organic compound, right? And based on that, I have few question ahead. Okay, so the question is, why concentrated H2SO4 used in COD analysis? To increase temperature, to neutralize ammonia, to dissolve organic matter, to provide acidic medium oxidation. Oh, we are not neutralizing ammonia, Deepa. We are providing acidic medium for the oxidation, because oxidation is maximum in the acidic condition. So yeah, D answer will be the right one. Yeah, so if you can see here, uh, that H2SO4, that H2SO4 will give us the H plus ion, right? So you will have some H plus ions and you will have some electron, and based on these conditions only, your dichromate oxidation state was -2, and it will change to 3 plus. So what it is, losing or gaining the electron. Can you tell me either it is losing or gaining the electron? So it is getting oxidized. So oxidized means it is gaining or losing the electron. This is just very simple thing. Losing the electrons, right? So, and yeah, so that's how it is very important that and whenever we are losing the electrons, right, that electron, it should be react with something also. So that's how, if we have H plus ion, if we have electron, and that's how it can give you the water. So yeah, so the only thing is that dichromate will be strong oxidizer only in the acidic medium. COD determination, FAS is used. What is the purpose of this FAS? titrate excess dichromate, neutralize acid, oxidized organic matter, act as indicator. I showed you the picture of that, the procedure, how we can calculate the COD, and at that picture at the end, there was FAS. So FAS is used for what? Yeah, it will titrate excess dichromate. So what we are doing is COD is a simple process. So let's say we have some organic compound here, right? If we have organic compound here, and if we are adding dichromate in it, okay, some of the dichromate will be used to oxidized organic compound, right? But some of the dichromate will be remaining here, okay, because we already have oxidized, but we will have some excess dichromate in that beaker, right? So let's say if we had 20 milliliter of dichromate, but uh, it took just 20 ml to oxidized, but we will have 80 ml that is remaining, that is not oxidizing our organic compound, because it already has oxidized, but we can't measure it directly, that how much has been taken up, or how much we are left with the dichromate. So what we will do is, we will have the FAS. If we are titrating it, if we are adding FAS into it, FAS will start reacting with the whatever we have, this 80 milliliter a dichromate that we have, the excess dichromate we have. So it will start reacting with this left dichromate, and whenever all left dichromate will have reaction with FAS, the color will change. So how much FAS is used will give you how much dichromate we are left with, and we already know the known amount of dichromate that we used. So this will give you the value of this one, how much we have used for the organic compound to oxidize, and this will give you the value that we want, right? So this is how the procedure to calculate the COD. So here the word that excess means the remaining one. So 20 ml has been oxidized with the organic one, and 80 ml may be remaining, and it will react with the FAS. And whenever all will be um, all will be reacted to FAS, then the color will change, and this will give you how much DC we had. And based on that, we already know the known amount of DC, then we can calculate how much DC we used to oxidize the organic compound. Okay, so yeah, so that's how A answer is the right one. I already have discussed about this, then I'm not going to. Okay, so yeah, this is very important. Whenever we have more FAS use, it means we have less organic matter present. This is obvious. Why this is obvious? Because we have to add more FAS, because we have more unused dichromate. Okay, if we have more organic compound means more dichromate is already used. Only less amount is left that will react with the FAS. So whenever we have more FAS we are using, it means we have less organic material that we have in the sample. Okay, so whenever the color is changing, it means we are using some indicator. So what kind of indicator we use in the COD titration? Methyl orange, phenolphthalein, furan indicator, starch. Okay, Deepa, C or D? You're right, C or D, but which one you are thinking more right? Okay, Chechi already have given the answer. That is C, and that is the furan indicator. Yeah, so I agree with this one. Uh, for COD titration, whenever the color is changing, and because we are adding some indicator, and that indicator is furan indicator. Yeah, C answer is the right one. Yeah, you already know about this. Okay. Now we are moving to the next topic, and this next topic is total carbon and different type of carbon we may have in the sample, right? So you need to tell me the total carbon is related to TOC and IC, and how it is related to that. I have four options. TC is equal to TOC minus IC, TC is equal to TOC plus IC, TOC is equal to TC plus IC, TC is equal to IC only. If you know the full form of this, I think this is very easiest thing that you can tell. What is the full form of TOC and what is the full form of IC? Then we may have answer like very clearly in our mind. Okay, let me see. Uh, so yeah, B should be the right one. Yeah, you correct it. So TOC is organic, total organic, organic carbon, and I is inorganic. So total carbon will be organic plus inorganic. So the right answer should be B. Total carbon is equal to organic part of the carbon plus inorganic part. So B answer is the right one. And but yeah, the complexity will come when you need to measure total organic compound, how you will calculate or measure total organic compound, or how you can measure inorganic organic carbon, and how you can measure inorganic carbon. This is like a little not challenging, but yeah, complex. So I think a few questions are related to this. In modern TOC analyzer, organic carbon is measured by UV absorption directly, titration with acid, oxidation to CO2 followed by IR detection, gravimetric filtration. We have one analyzer that is known as total organic carbon analyzer. How we can measure C as organic carbon? Okay, Chechi gave me a C answer, oxidation to CO2 followed by um, IR detection. But the question is, um, okay, I give you, let's say, first, can you give me the one example of inorganic carbon? Can you give me one example of inorganic carbon? In organic carbon, I'm taking the example of glucose, C6H12 or 6. What is the example of inorganic carbon? Can you tell me? Have you heard about carbonates and bicarbonates? HCO3 and CO3 2 minus. Okay, so whenever we are adding some oxidizing agent, okay, whenever we are adding some oxidizing agent, that can convert everything into CO2 and water. So the question is, we glucose plus carbonate both are giving to the CO2 and H2O, and that will be detected by infrared detector. But how we can calculate then organic carbon? This is giving us the total. This is this is giving us the TC. And here, this is not exactly the oxidation. Sorry, this is oxidation by, but by this oxidation is by combustion. So what we are doing is we are burning everything. So whenever we are burning everything, so everything, either it is organic carbon or inorganic, everything will give you the CO2 and H2O. So and then this will give you the CO2. Whatever CO2 we are having, that will be detected by the infrared detector, and that will give you the concentration. But this is giving me the total carbon, but this is not giving me total organic carbon. You're right, C is the right answer, because this step we have to follow somehow. But my question is, uh, uh, this oxidation is giving you total carbon. It is not giving you the organic carbon. We have to have one more step. Then what more step we may have? So what you can do is, you have total carbon, right? And total carbon, you will have organic plus inorganic. But whenever you are adding some oxidizing agent, not combustion, but you are adding some reagent, right? For example, what you can add, some acid you are adding. That acid or that oxidizing agent will only oxidize this inorganic. It is very difficult to oxidize the organic one. Okay, so this inorganic will give you the CO2 and then some water or something, right? Then what we have to do is, we have to remove this CO2 first. We will remove this CO2. We have some method by which we can remove this CO2. Then whatever left will, we will have this organic one. And then we will do the combustion. And then after combustion, whatever CO2 we will have, that is organic carbon concentration it will give. So what we are doing is, before combustion, first we are adding some oxidizing agent, and that oxidizing agent is oxidizing only the inorganic part. And then whatever CO2 will be due to inorganic, we are removing that CO2, and then we are having that combustion process, and then this will give us the organic part. So yeah, C is the right answer. But before that, we have to follow one step. The another way, maybe, the thing is, we can directly do the combustion, but we should have same sample, for which we can add the oxidizing agent, and we can calculate the concentration of inorganic, and then we can subtract it. So these are the two ways by which, so calculating the organic compound is either two step or indirectly after calculating the inorganic one. So yeah, I already have discussed about these things. Then I think I should remove this. Yeah, just see here, we have two methods that I discussed about this. First, you can remove the inorganic part. And how you can remove inorganic part? You need to add the acid. If you will add the acid, that acid will not remove the organic part, but will remove only inorganic part. This will give you the CO2, and you have to strip it. You have to remove it with air, and then you are having the combustion, and then that will give you the CO2, and that CO2 we can detect with the NDIR. Okay, the second way is the, you are measuring total carbon, but You have same kind of sample, and you are acidifying it, and then you are subtracting it. So these are the two methods by which we can calculate the organic carbon. Okay, we have one more type of carbon, NPOC. What do you mean by this? Non-polar organic carbon, non-purgeable organic carbon, neutral particulate organic carbon, non-photochemical organic carbon. What different type of organic carbon I'm talking about? This NPOC. What is the full form of this? What is the full form of NPOC? So this is B part, that is non-purgeable organic carbon. So B answer is the right one, and you can just see here. So this is something, whenever we are acidifying the sample, we are converting our inorganic carbon to CO2, and we are purging this inorganic carbon with water, sorry, with air. Then whatever is remaining is the carbon that is non-purgeable organic carbon. So you can say the organic carbon, total organic carbon. So this is also like very similar to the NPOC, because some of the organic carbon can also volatile in nature or can evaporate. So whatever will be remain will be non-purgeable organic carbon. Okay, I think you know the right answer for this. We do the acidification in NPOC analysis. Why? Oxidize organic carbon, increase temperature, convert inorganic carbon to CO2 for removal, improve IR sensitivity. As I told you, why do we add acid? Acid can change inorganic carbon. Yeah, the answer is the right one. So acid can convert inorganic carbon to the CO2, but it can't remove organic carbon. So first we have to do the acidification so that we can remove the inorganic carbon. So whatever remaining carbon we will have, that will be NPOC. So yeah, C is the right one. Mhm. You already know about this. Okay, so we talked about BOD, we talked about COD, we talked about TOC, and these are known as the bulk parameters. But why? Identify individual compound, measure total concentration of one specific pollutant, measure only biodegradable carbon, provide overall measure of organic load without identifying compounds. Yeah, Deepa gave me D answer, and you're right. Because each this analysis are not giving us what kind of compound I had in my sample. It is just giving me organic thing or inorganic, but it is not exactly saying that in your sample you have this much of glucose or this much of hexane or this much of benzene you have. So it is not giving us like we are not able to identify the compound, and that's how we have the limitation with this. Like these are the screening parameter, but these are not very specific, so that's how these are known as the bulk parameters. And because these are the bulk parameter, that's how we have to go for the speciation. So the next question is, speciation analysis in water sam quality means measuring total carbon, measuring total oxygen demand, identify individual chemical forms or species, measuring pH. I think the options are very easy to identify which one is the right one. So I got answer C from Deepa. Yeah. So C is the right answer. So speciation is so speciation is to identify what. So let's say we have 20 or 30 chemical in the pond water, and if we are able to identify what chemical, what heavy metals, or what different contaminants I have in the pond, if I'm analyzing, and if I'm able to identify each of this compound or each of this metal, then that will be come under speciation analysis. And that's very important for us because can you give me one advantage for speciation analysis? How why we want to know about individual chemical? Why we are interested to identify the individual chemical form? Okay, nature of pollutant, but nature of pollutant may be right answer, but not very to the point answer. The one I can say, if I know compound, and if that compound is, we know that if that compound concentration is beyond that, it means it may have some bad impact on the human, right? So it will be easier for us to do the bioassay or something. So for the toxicity and assessment, it is better if we have the each species or each individual chemical form we have. And the second one is for treatment. Okay, nature of pollutant for treatment. Yeah, that one is the important point that you made. Yeah, it is for treatment. You have to focus each particular chemical, and if you do not know the chemical, then the treatment will be very difficult for us. Then yeah, for treatment it is very important for the speciation. Then I add one more. If you know that particular sample have that particular contaminant, then you can find the source for it. So for example, we found that some mercury is coming, or in our water sample we have some mercury. Then we can find out the source. There may be some industry that is working in the petroleum or coal, so we can identify this mercury can is coming from what source. And then we can do some intervene to either to stop that industry, or to some impose some penalty, or to make some rules and regulation related to such kind of industry. So this is known as the source apportionment. So we are identifying the source after doing the speciation. So this is very important for us to know. So C is the right answer. Yeah, so we are identifying each particular chemical forms. So this is speciation. Bioassay is primarily used to measure total carbon, assess biological toxicity, measure oxygen demand, identify biochemical structure. So yeah, Cheshi gave me a response B, and that is assess biological toxicity. And yeah, so bias is something that we have rat, or we have some sample, or animals that we can use for the research. So if we are giving concentration of something to the rat, and if we are increasing or decreasing that concentration, and then we are seeing what kind of impact it have on the rat, either the brain is getting damaging, or lungs is damaging, or something like that. So it means that we are trying to identifying the toxicity level, and what will have it impact on each part of human, in the form of like after getting result from the rat, right? So this is something bioassay. So we are assessing the biological toxicity. So as you know that if we have if we have some compound, let's say if we have glucose, and if we have glucose 12 mg per liter in the sample, and that is also one contamination, but you have 1 milliliter, 1 mg per liter of benzene in the water, and then no doubt the concentration of this glucose is very higher, but the toxicity is very low. And how we will get this toxicity? Whenever we are giving that chemical to, let's say, rat, and then we are seeing what kind of impact it will have on the physiology, or on the rat body. And so the 1 mg per liter benzene may be like dangerous. So this is how, this is the part of biassay. Yeah, you must have seen such kind of things. Okay, which statement is correct? Bulk parameter provide toxicity information, speciation provides source information, bioassay identify chemical compounds, TOC identify toxic species. Deepa and Cheshi. Yeah, you both gave me B answer, and B answer is the right one. As I told you, speciation will also give the source information from where it can come, right? And that's how B is the right answer. Okay, now we are moving to extraction to analysis part, and yeah, to the instrument. We are moving to the instrument part. So we have this LLE. What is this? Liquid extraction, right? So you have, let's say you have pond water, and pond water have some contaminant A or component A, but you have to remove this water, and you have to put that A into some solvent. So this was liquid and this is liquid. So we are extracting the A from liquid to another liquid. And so you have to tell me which solvent property is most important for liquid extraction. High miscibility with water, chemical reactivity, immiscibility with water, high boiling point. Okay, I agree with the C, but not A. I think you are confused with miscibility and immiscibility. The thing is, if, let's say, because the pond here, if I'm taking the pond water, so this is the pond water, and solvent, if I have any solvent, let's say the solvent is known as X. Okay, and how I can put that A, how can I extract that A from pond water to the solvent? So first what I have to do is I have to mix this pond water to the solvent. Okay, but if pond water is highly mixing with the solvent, then pond water and solvent will be mixed, and A will be mixed with the pond water and the solvent. So you can't extract A in the solvent. You need to remove that pond water. So for that, your solvent should not be completely mixed with the water, right? And that is, in technical term, we can say that our solvent should be immiscible with the water, not miscible. This is just opposite to the this one. Okay, it yeah, so that's why, if, let's say, if the water is, mostly water is the polar, right? And so most of the time solvent are non-polar. So even when we are mixing it, it will not mix, but because the compound A may be organic or may be non-polar. If it is a non-polar, and if we are having the solvent non-polar, then if we will mix it with the pond water, then solvent will take all the component A, but will not mix with the pond water. And that's the property we want to extract A into the solvent, and that's how A is not the right answer, but C is. Okay. Which solvent is suitable for extracting PAH from water? PAH is polycyclic aromatic hydrocarbon. Which solvent we mostly use to extract such kind of compound from water? Just see, water is polar, pH is non-polar. So to remove non-polar, we need the solvent that is non-polar in it. Chechi gave me C answer, and yeah, C answer is the right one, because hexane is um, hydrocarbon only, and this is non-polar in nature. And so we can remove this pH using hexane. So if we are mixing that hexane into water and water have the contaminant, then there will be two layer, and hexane layer will have pH, and then water will be empty one, and then we can remove this water. So yeah, hexane is the right answer. If suspended solids are not removed before extraction, what may happen? So if you have pond water may have some solid, suspended solid. But if we our interest is to calculate the PAH concentration, so so what this suspended solid will do? Higher accuracy, emulsion formation, faster extraction, no effect. Chechi gave me B answer, that is the emulsion formation. What do you mean by emulsion? What do you mean by emulsion? What it is? If you want to extract, let's say, PAH, but in the pond water we have suspended solid, and then we are extracting that PAH, then what will happen? These are the colloidal solid. Yeah, you can say about this. I already have given some things that what this emulsion is. So emulsion is the tiny droplet of one liquid that are dispersed in another liquid and that do not separate easily. So milk is the example. So milk is what? Fat in the water, and you can't separate it, right? So this is something emulsion. So because of this emulsion, you will get a very cloudy mix layer, a middle layer, and that's how removal of this water from solvent and then contaminant, it is very difficult for us to remove this because there will be the cloudy middle layer. And that's how we have to first filter out the pond water, let's say, to remove the suspended solid, and then we will go for the extraction. Okay. um, which of the following can cause interference during LLE, liquid liquid extraction? Nitrogen gas, oil and grease, pure distilled water, sodium chloride only. If you are extracting, if you are extracting any compound A from any liquid to another liquid, what can cause the interference? Sodium chloride mostly do not interfere with this extraction process. I will tell you why in the uh, next slide only, I think. Okay, so now you gave me a B, and Deepa also gave me B. Yeah. So this is oil and grease. But how oil and grease can interfere with this extraction, liquid to liquid extraction? I have given some explanation, I think. So yeah, Uh, so oil and grease are mostly non-polar, hydrophilic, not liking the water, right? Hydrophobic, sorry. Soluble in organic solvent. They can be so the thing is, they can be soluble in the organic solvent. So it means that grease and oil will come along with our interested compound. So our interested compound is, let's say, A, and if we are removing this A to some, we are moving it to some solvent. So it may be water, or there is some solvent that is, let's say, hexane. So if we will have oil and grease here, because oil and grease also have more affinity to attach to this hexane. Okay, so along with A, oil and grease will come in this solvent, and then it means they will be co extracted with the analyte. That will increase the background noise. They may contaminate gas chromatography. We will talk about this, and that's how it will give us the poor peak. And this is also known as the matrix in interference. Okay. Okay, I think this question will help you to give you the explanation why NaCl is not the interference. So if we are adding NaCl during extraction, what it will do? Decrease extraction efficiency, increase analyte solubility in water, force analyte into organic phase, causes oxidation. I give you the hint that NaCl is not the interference, but it is helping for the extraction. It is helping the extraction process. Increase analyte solubility in water. No, this is analyte should not be soluble in water. If it is the more soluble in water, then it will be very difficult for us to extract that analyte to the solvent. And I told you NaCl will help the extraction process. So yeah, it is forcing analyte into organic phase. But how it will force? Because I told you, um, let's say we have water. Water is polar in nature, right? Water is polar in nature, and most of our analyte are organic, are non-polar in nature. Obviously there is no solubility, and we do not want more solubility of this analyte into water. If we will add more NaCl, NaCl will occupy the water, will bind to the water, and that's how this will leave the analyte free. And that's how whenever we are adding the solvent will directly will bind to the analyte. So it means it is giving the space to analyte to bind to the solvent, because it is because water is making some reaction with NaCl, and that's how our analyte will be free. Okay, so if it is a free, then it means more extraction efficiency will be increased. So C answer is the right one. So here I gave you explanation. Salt ion bind with water. So water molecule will be less available to dissolve organic, and organic compound will become less soluble. That means analyte is pushed out of the water, and that's how it is helping. Okay. Uh, for the filtration, if we are doing any filtration, standard method typically use 10 micrometer cellulose paper, 1.5 micrometer glass fiber filter, 0.1 micrometer membrane filter, 5 micrometer nylon filter. Filter is for filtration, right? You people already have used the filter paper. So if we are talking about the standard method, one standard method, and yeah, So this standard method is SM. It is for the solid, right? So if we are extracting the solid, right, we should have first filter paper. So what kind of filter paper we will use? Um, Deepa gave me B answer. That is 1.5 micrometer glass fiber filter. But yeah, you are right. Actually, the answer is right. But why? Why you are using 1.5? Why you are not using 10 micrometer, and why you are not using zero point 0.1 micrometer? It is obviously that you can't use 10 micrometer. Deepa told me standard, but why this is the standard? I'm asking you why we created such kind of standard that we are using 1.5 or near to 1. So mostly for the standard we have 1 to 1.5. But why this 1 to 1.5? Why standard is using that? What is the comfortableness that standard got when they have such kind of filter paper? Why not 10 micrometer is the standard? Why not 0 0.1 micrometer is the standard one? You have most organics are in that range or above that range. You are perfectly right that mostly these are in range, but it is isn't it better to use always the filter that have very smallest pore size, let's say zero point 0.1, so that we are 100% sure that, yeah, every organics we can collect. So why we are not using uh, zero point 0.1 micrometer so that we have 100% efficient? Okay, Deepa told need vacuum cannot strain. Yeah, you're right. So because it will be clogged, and the pressure will be dropped. Yeah, pressure drop will be very high, and because of this we have to use vacuum, and it will be very expensive and very tedious work to do. So, and the one thing more is that even then, even if we are using that vacuum and all, so but whatever mass or weight we will get, uh, after using that zero point 0.1, there will be not much change because it has very less size and weight will be very low. So we are not losing, we are not losing more. So that's how for the standard it is 1 to 1.5. Okay, the next question is pressure drop increase during filtration mainly because water density changes, filter become clogged with solid, vacuum pump weakens, pore size increases. Yeah, Deepa gave me right answer, and we already have talked about this. Uh, uh, if we have a pore size is very small, it means it will be clogged by solid, and then uh, gravity will not help us. Gravity will not help us to strain it, and here the pressure drop will be increase, right? So B answer is the right answer, which is true. uh, Glass fiber filter have uniform pore size. Glass fiber filter block dissolve solid. Membrane filter allow faster filtration. Membrane filters have precise pore size. Okay, Chaisha gave me D answer, and yeah, I also agree with this because uh, when the pore size is more, the first thing is when the pore size is more, this is mostly made up of the glass fiber. If the pore size is very small, then this means we are using the membrane filter. Glass fiber filters have a non-uniform pore size, but if it is the membrane filter, then it have very small and very precise pore size. So yeah, the answer is the right one. Okay, now we are moving ahead. We are moving to the concentration. We talked about, we have extracted, right? So we have pond water have A, and now we had extracted it to some solvent. Let's say the solvent is hexane. So now we have uh, A in hexane. But the next thing is, we have to remove this hexane also, so that we can concentrate this A, so that the concentration of A can be increased, and then we can use the instrument, for example, GC or LC, something, gas chromatography or liquid chromatography. So this is the important part, concentration. So for concentration, we have some method, and one of the method is rotary evaporation. And the question is related to that only. Rotary evaporation reduces boiling point mainly by increasing pressure, applying a vacuum, adding nitrogen, cooling the flask. So the thing is, we have to remove this hexane, right? We have to remove this hexane. We have to evaporate it. We have to evaporate this hexane. But how we can evaporate it? So we have one instrument, that is rotary evaporator, you can say, and in which we have very specific parameter, that is the boiling point that we have to maintain. And because more the boiling point we will have, more evaporation we can do, right? But if we will have more boiling point, then our A can also evaporate. So we want to reduce that boiling point. We want evaporation, but we want to reduce that boiling point. How we can reduce that boiling point? Any hint about this? Okay, Chechi gave me a B answer, that is applying a vacuum. Yeah, you're right. So for example, if you have this hexane and you have A, and you have heater here, you are heating it, right? But you do not want to heat it more, because A will also go out. Okay, so what you want to do is, you want to heat it, but very like not very high temperature. Okay, so and you want to evaporate this hexane. So what you are doing is, you are having some vacuum pump here. So this vacuum is drawing this hexane, right? Whenever it will draw, then we can keep our boiling point low only, and evaporation will be possible, and that's how we can concentrate. Okay, so this is applying a vacuum. So this is something that I wanted to show. So this is your rotary flask, right, in which you have solvent, and you have your compound A, and here you have water bath, that is giving you that is giving some temperature. And what will happen, and you want to remove this solvent. So what you are doing is, you are having the pump, a vacuum pump. So this is removing this solvent here. Okay, and that's how you will have A, remaining A, that have very high concentration A. So this is, you are concentrating your sample, so that you can use it to the instrument. Okay, so this is the one method of concentration. Okay, the flask rotate in rotavapor. The flask will rotate. Why? That will increase the pressure, increase surface area, and prevent bumping. Cool solvent, separate analyte. Why the flask? Why the flask does rotate? So this is your rotatory flask, and that rotate. Why? Why we do have rotatory? Why we do not have that still flask? What will help if we are rotating it? The main reason is because here we have water bath, right? We are giving some temperature. If we will give the temperature, there may be the boiling, right? And boiling will make you lose your A also. Okay, because there so this is something, bumping will help, and bumping will evaporate A also. So if you are rotating, then it will prevent the bumping condition. And the second thing is it is increasing the surface area also, and that's how evaporation of your solvent can be higher. And I think I have one slide to show you what do you mean by this bumping. So bumping is sudden, violent boiling of the liquid during evaporation. So instead of smooth boiling, the liquid may superheat because we are having the water bath, and then suddenly it can release the vapor and it can explode or something. So that's why we are rotating it continuously. Then another method for concentration is nitrogen blowdown. And but how it works? So I have four options: oxidizing solvent, increasing solvent vapor pressure gradient, increase pressure in vial, cooling sample. Nitrogen blowdown is again one method to concentrate your analyte. Um, no, the working principle is not cooling sample. What is the like how nitrogen blow down can increase the concentration of the analyte? By cooling the sample, we can't increase the concentration of analyte. Yeah, B is the right answer. We are increasing the solvent vapor pressure gradient using nitrogen. So for example, you have this solvent S and you have A, that is the compound, then you are putting a lot of nitrogen into that. So this is known as the nitrogen blowdown. If you are adding a lot of nitrogen, then you are increasing the vapor pressure gradient of this solvent, and solvent will go out. I have the picture of this nitrogen blowdown. Yeah, something like this. You have solvent, and these are the needles. The needles are giving you um needles are giving you nitrogen, and whenever you are putting nitrogen into your solvent, then your solvent will go out. So this is the another method to concentrate. If we have too much nitrogen flow, then what will happen? Evaporation stops, analyte may be lost, pressure decrease, temperature decrease. If we are putting a lot of nitrogen in the solvent and analyte, what will happen? If the flow is too high, no, why temperature will decrease? There is there is no any significant relation between nitrogen flow and the temperature decrement. But this is something, if we are having more flow of the nitrogen, your analyte may also evaporate because it is increasing the vapor pressure gradient, right? Yeah, so B is the right answer. Okay, so you learned two method. The first is rotary evaporator, and second you learned about the nitrogen. You learned about that nitrogen method, right? So which one is more gentle for heat sensitive compounds? high temperature open evaporation, rotary evaporation with vacuum, direct heating on hot plate, boiling under atmospheric pressure. If you want to concentrate, right? And if we are doing the evaporation, so what method will be more accurate for concentrating? Among here, the option is not for the nitrogen, right? So we will have to rely on rotary evaporator. At least it is rotating, at least it has vacuum, so that boiling, we are reducing the boiling point. We are not giving high heat it, because we are having the vacuum. We are reducing that boiling point to insert that vacuum. We are rotating it so that the boiling is not high. So so for the heat sensitive things, we can rely on rotary evaporator if we do not have that nitrogen based option, right? So B answer is the right one. I think we can stop here. And so this is the part of the concentration. We talked about the extraction. We talked a little bit about the concentration, and we have questions on chromatography that is important for us to learn. And I think in next week we can start with gas chromatography and liquid chromatography. This is very important topic. We have different type of detectors. In this we have mass spectrometer, because what we were talking about the speciation, right, to identify what chemical we have. So for that we have particular instrument. So knowing about this instrument is very important for us. So I think next week we can start I think with two or three questions related to, I think, this concentration part, and then next question will be related to gas chromatography and liquid chromatography with different detectors, right? So we will talk about this in next week. Till now, happy reading, and yeah, thank you so much. Thank you so much. We will meet again on Tuesday from 6 to 8 p.m. So thank you so much, AJ. And you can leave and have a good dinner.